Okay, I'm gonna start out with part A of this number one free response. So they give us a table with three molecules, HCl, HBr, HI, and they give us the boiling points, the dipole moments, and the polarizability. So as you can see, the boiling point is increasing as you go down, the group, because these are all in group 17. They're all halogens. So part A is asking what type of intermolecular force explains this trend in boiling point. So as you can see, the dipole moment is decreasing as you go down, but the boiling point is increasing. So this doesn't seem to explain it. But if you look at polarizability, which is dispersion forces how easy it is to polarize the molecule. As the polarizability increases, the boiling point also increases. So the answer to that question would be dispersion forces. The dispersion forces are why the boiling points are increasing, because these molecules, chlorine, bromine, iodine, they're getting bigger, so they have more electrons, so the dispersion forces are greater. Okay, so moving on to part B, this student predicts boiling point of HF should be 174 because they expect it to be less than this because HF has less electrons than HCl. But the boiling point is actually 293. It's much greater than even HI. So the reason this happens is because of hydrogen bonding. So we know that carbon, nitrogen, oxygen, and fluorine all can form hydrogen bonds, which is an intermolecular force. It's a type of dipole moment, but it's much stronger than any of them. And that is why the boiling point of HF is so high. So it doesn't follow this trend, polarizability, but it's because of hydrogen bonding. And then part C, it shows us a box with a liquid. It shows the molecules, and it asks us to draw a representation. So this is what it would look like, because the gas would expand more. If we had vectors, you'd see that they're all going in random directions, and yeah.